No, it's not torturous. This is a relatively okay question. Equation of DC, part 1. I see from my diagram. Okay, class, listen. These are the information given. I hope eventually you will be able to have this thought process. Okay, I see that point C is not given to me. I see that I've got A, B over here. The coordinates are given. So in my mind, I know that I can find equation of AB. Okay, if I know equation of AB, it means that I know my gradient of AB and my y-intercept of AB. I can find all this. And since there is a perpendicular line, BC over here, it means that I can find the gradient of BC. Gradient BC times gradient AB equals to -1. Since I know the gradient of BC, I can find equation of BC. I can find equation of BC because I have one point and I have the gradient. Now since I have the equation of BC and I have the gradient of DC plus 1 point, I can find gradient of equation of DC. With these two equations, DC and BC, I can find the point of intersection, right? Because BC, the equation of BC is actually along this red line, whereas the equation of DC is along this blue line. When I have these two equations on the same axis, they intersect, it tells me that I am supposed to do my simultaneous equation. Because in BC, there's one over here. Sorry, no. DC, the blue color line. Every single coordinate will satisfy this equation. And every single coordinate on BC will satisfy this equation. But there is one certain point. There is one very special point over here, point C. It satisfies both at the same time. They satisfy them simultaneously, which means we do it simultaneously. Simultaneous equation. Okay? So this is the thought process. And now we are ready to do. Gradient DC equals to gradient AB, which is 8 minus 2 over 16 minus 4. We get 4 over 6 over 12, which is half. So I substitute that to find the equation of DC. So 10 equals to half times 5 plus C. C equals to 7.5. So equation of DC is y equals to half x plus 15 over 2. Now, gradient of BC times the other gradient is half equals to -1. So gradient BC must be equals to -2. Yes? Did you eventually get -2? So what do you write? Okay, can, because you already have the half. It's understood that you are capable of doing that mental sum. -1 divided by half is -2. So we substitute in the coordinates of B because it lies on our line BC. No other coordinates given to us already. 8 equals to -2 times 16 plus C. C equals to 8 plus 32, which is 40. So y, this is the equation of BC, is y equals to -2x plus 40. And now to find the coordinates of C. Yeah, these are our two equations. Equation number 1, equation number 2. Solve equation number 1 and 2 simultaneously. Get x equals to y equals to. Find out yourself. Length of CD, I don't need to go through. Just straightforward apply the formula. Now take a look at practice now 7. Read the question first. Don't need. Part 1. Equation of BD. What should we find first? Okay, gradient of what? Or CA. Find the gradient of CA, yes? All of you able to find gradient of CA? Okay, so once that is done, what do we want to find next? Okay, so gradient BD equals to -1 over gradient CA, right? So we can find this. Okay, so what if you get gradient of BD? No. They want the equation, midpoint of CA. Can do it? Okay, now that you have the midpoint of CA, you have the gradient, what do we do? Sub into y equals to mx plus c. So to find the value of c. So part 1 done. Okay. Now part 2. Find the coordinates of B. Okay, so part 2 sub what? Okay, sub y equals to 0 into equation of BD. All of you agree? Because y equals to 0 will be my x-axis. I know point B lies on the x-axis. It has the coordinates x, 0. So I sub y equals 0, I will naturally be able to find x. So I am able to get the coordinates for B. So that's done. Now part 3, find the coordinates of D such that A, B, C, D is a parallelogram. How do we do part 3 then? I heard gradient. How do we use gradient to do that? Gradient of CD and AB are the same, is it? Yes? Okay, they are the same because they are parallelogram. So what if I manage to find gradient of AB, I equate it to gradient of DC. Wait. Let's try the parallel lines first. So this one I can get gradient AB equals to a constant. We can find this value. Then if I want to equate it to gradient of CD, you require another point over here, right? Let's call this x and y again. So the gradient of CD will be y minus 3 over x minus 1. Do you see that if you equate this to a constant over here, you have two unknowns, only one equation? So cannot solve yet. Then how? Yes, we can find the equation of BC as well as AD. Then you get another constant over here. Then you have another y minus 1 over x minus 6. And these two are equal. So you have two equations, two unknowns to solve for point D. Alright? That is how it can be done. But there's another way. Much easier. It requires the application of this property of a parallelogram. For a parallelogram, there are diagonals. They bisect each other. Okay? How are we going to use this for our question? So we found many things already, right? We found the midpoint of CA. So we don't want all this. We don't need all this. We also found the value of this x. So midpoint of BD equals to the midpoint of CA. you already have the midpoint of CA. So we let this be xy for the coordinates of D, which implies that this value of x, let's call this xb. Earlier we already found it. Xb plus, okay, for convenience, let's call this xdyd. Xb plus xd divided by 2, comma. This one, xb we already found. This is our question mark. The other will be 0 plus yd over 2. It's supposed to give us the coordinates of the midpoint. So m, x of the midpoint, y of the midpoint. You understand? So all this we have already. We just need to equate this. So you see, I've got unknown, known, and known. One equation, one unknown, and fine. Similarly, for the y value, this is known already. This is my only unknown. I can find y. Okay? So that is how we use the property of a midpoint in order to find this unknown coordinate. Any questions? Any questions? Why are the midpoints the same? It is a property of parallelograms. Just like the diagonals of the square, they also intersect at the midpoint. Can? Yeah. But that's why part 3 then we talk about, that's why we are doing part 3 now. Okay. There is the homework for this topic. Exercise 5C, question 489.